Hi, welcome back to my channel. My name is Robin. In this section, I would like to teach you how to convert fractional numbers in base 10 to other bases. Let's dive right into it. So now we have on the screen to convert the following in base 10 to binary number. And you know binary number simply means base 2. So in this case, let's start with the first question. The first question is A, so 7 over 8. 7 over 8 is in base 10, okay? 7 over 8 is in base 10, and we are converting this to base 2, right? So the first thing you need to understand here is power principle. The power principle is based on the base we are converting into. So we are converting it to base 2 here. So all you need to do, you write 2 and you start to put power on 2. Make sure that the power you are putting start from 0. So I will say 2 raised by 0. After 0 is 1. After 1 is 2. After 2 is 3. After 3 is 4. After 4 is 5. Continuation like that. Okay. So now, remember, 2 raised by 0 is 1, 2 raised by 1 is 2, 2 raised by 2 is 4, 2 raised by 3 is 8, 2 raised by 4 is 16, 2 raised by 5 is 32. This is the formula we are going to use. So this is how you create that formula that you are going to use. Now, let's put this on the corner, okay? So how do we use this formula? We'll see. Remember, we have 7 over 8. 7 is known as the numerator, right? What is up on the fraction. Then 8 is known as denominator. That means what is down on the fraction. So you have the numerator and the denominator. But in this case, we are only interested in the numerator. So numerator is equal to 7. So the formula, the principle here says that what can I add together from here? What can I add together from here that would give me 7, which is the numerator? What can I add together? I can add 1 plus 2 plus 4. That would be 7. 1 plus 2 is 3. 3 plus 4 is 7. So I can say 7 can also be written as 1 plus 2 plus 4. Remember, I can say 8 minus 1 is 7, but we cannot use subtraction. It has to be addition. That is why I'm saying, what can I add together that will give me numerator, which is 7? 1 plus 2 plus 4, that is 7. So now, we come back here. 7 over 8 is equal to, what is 7? 7 is 1 plus 2 plus 4. Just put the denominator there. Okay? Put the denominator there. Right. Now, another thing is 1 over 8, 1 over 8, okay, plus 2 divided by 8, that is 1 over 4, plus 4 divided by 8, that is 1 over 2. Right? Good. Now, 1 over 8. What is 8? What is 8 here? 8 is what? 2 raised by 3, which is that, plus 1 over 4. 1 over 4. What is 4? 2 raised by 2. That is that. Then 1 over 2. What is 2? 2 raised by 1. That is that. So that is why I said this is very, very compulsory for you to understand how to make that. Now, the next thing is, I will quickly put a reminder for you. Remember, in indices, if you have 1 over a raised by b, is same thing as a raised by minus b. Okay, so that simply means if I have 1 raised by 2 raised by 3, 1 over 2 raised by 3, that is 2 raised by minus 3. Now, this is it. We have 7 over 8 is equal to, you already know that
this one here is the same thing as 2 raised by minus 3. This one here is same thing as 2 raised by minus 2. And this one here is same thing as 2 raised by minus 1. So at this point, I would like to explain a very important concept to you, which is the law of omission and law of presence. So here, law of omission and law of presence. Law of omission simply means if something is missing, you use 0. If something is present, you use 1. Now, how do we use this law? I will explain. Okay, so let's assume I have something like this here. I'm just using an assumption. An example, sorry. Now, put your mind on this. This is a number line. Okay? So, we want to start from minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, like that. So, we'll always start from minus 1. We will always start from minus 1. Okay? But that is we looking at the power. Okay? That is what we are interested in. We'll always start from minus 1, looking at the power. So, let's start. Minus 1. Is minus 1? We are starting from minus 1. Is minus 1 present here? Yes, minus 1 is here. So if it is present, I'll use 1. After minus 1 is minus 2. Is minus 2 present here? Because this is minus 1 and it goes to minus 3. So there is no minus 2 here. So because minus 2 is omitted, I will use 0. Because I said anything that is omitted is 0. Anything that is present is 1. So after minus 2 is minus 3. Is minus 3 present here? Yes, I use 1 because it's present. After minus 3 is minus 4. Is minus 4 present here? Yes, I will use 1. After minus 4 is minus 5. Is minus 5 present here? Yes, I use 1. After minus 5 is minus 6. Is minus 6 present here? No, it's missing. I put 0. After minus 6 is minus 7. Is minus 7 present here? I use 1. This is how to use law of omission. I give you an example again. Let's start with this. Okay. Remember, we concentrate on the power. And we'll always start from minus 1. Okay? We'll always start from minus 1. So is minus 1 present here? No. Because this is starting from minus 3. So minus 1 is not present. I will use 0 because it's omitted. After minus 1, we should go to minus 2, right? Is minus 2 present here? No, it's starting from minus 3. So minus 2 is not present. I put 0 because it's omitted. After minus 2 is minus 3. Is minus 3 present here? Yes, minus 3 is here. I use 1. After minus 3 is minus 4. Is minus 4 present here? Yes, I use 1. After minus 4 is minus 5. Is minus 5 present here? No, because this is minus 6, so minus 5 is absent. After minus 5 is minus 6. Is minus 6 present here? Yes, so I use 1. So after minus 6 is minus 7. Is minus 7 present here? Yes, I use 1. So this is it. So now, you know how the concept works now, okay? So let's get back to our question. So 7 over 8 is equal to, now let's use the law of omission and present now. Remember, we can rearrange this. Let's rearrange this, okay? I'm just rearranging it to start from what we have. You can see minus 1, minus 2, minus 3. I'm just rearranging it, okay? So let's use law of omission. Law of omission says we are concentrating on the power and it must start from minus 1. Is minus 1 present here? Yes. After minus 1 is minus 2 is present? Yes. After minus 2 is minus 3 is present. Okay, so 7 over 8 in base 10 is equal to, remember that this is a fraction, okay? no whole number. If it is a fraction, because 7 over 8 is a fraction, I have to say 0 points, because this 0 is taking care of the whole number part. It's taking care of the whole number part. So don't worry about that. You will see what I mean in the next example. So 0, just put 0 point if you have a fraction here. So you have, so for 7 over 8, I have 1, 1, 1. So I'll put, after the decimal, I'll put 1, 1, 1. So what I'm trying to say now is 7 over 8 in base 10 is equal to 0.111 in base 2. Okay, don't worry about it. Second example, you have more understanding. So let's go to the second example, B. B, 15 whole number, 7 over 8 in base 10. We are converting to base 2. Remember, since it is in base 2, we have used our base 2 to generate this formula. Okay, if it is in base 3, you will use your base 3 to generate this formula. But because we are talking about base 2, you remember how we used our base 2 to generate this formula. Okay, so now here, you have whole number and you have a fraction. Okay, you can see for A, we only had fraction. But now we have whole number and a fraction. So what you need to do, you have to take care of the whole number part first. So let's take this one to base 2. Remember how to convert from base 10 to base 2. I have done this in my previous video. If you don't know how to do this, click on the top right hand corner so that you can go to the previous video to learn about that. So this is done by successive division. So 15 in base 10, we are converting to base 2. So 7, remember 1, 2 here, 3, remember 1, 2 here, 1, remember 1, 2 here, 0, and 1. So 15 base 10 is equal to 1, 1, 1, 1 in base 2. Okay. Now, let's go to the fractional parts. 7 over 8 base 10. Okay, we already did this for question A. So, and we got 0.111 base 2. So in this case, I can say 15 7 over 8 in base 10 is equal to, what is the whole number solution, which is this, 1111. Okay, now we want to write the fractional part solution, which is this. I'll put point, which is this point here. Then the next thing is 112. So 1112. So this is how to convert a fractional number in base 10 to base 2 or to binary number. Don't worry about it. I'm going to take question C so you have more understanding about that. Let's dive into question C. Okay. Now, let's take question C. So C, 27 over 32 in base 10 to base 2. Now, we have used our base 2 to generate this formula. Okay? Remember, if it is base 3, you will use your 3 to generate this formula. So now, here, we have 27 and 32. This is our numerator. And this is our denominator. Okay? What is important for you here is the numerator. Our numerator is 27. So let's see what can give us 27 here. 32 is already greater than 27, so we cannot use this. Let's go to 16. 16 plus 8, that is 24. And we're going to 27, so we need 3 more. That is 2 and 1. So 27 is 1 plus 2 plus 16 plus 8. Or, let's write it this way. Let's write it this way. We can write it 1 plus 2, yeah, plus 8 plus 16 is better. Let's follow 1 plus 2 plus 8 plus 16. That is 27. So 27 over 32 is equal to What is a numerator? 27. What can give us 27? We said it's 1 plus 2 plus 8 plus 16. Now, you put your denominator 32, 32, 32, 32. Okay? So here, this is 1 over 32 plus, how many 2 can you get in 32? That is 16. 1 over 16. How many 8 can you get in 32? That is 4. 1 over 4. How many 16 can you get in 32? That is 2. That is 1 over 2. Okay? So here, this is 1 over. What is 32? 32 is something as 2 raised to the power 5. Okay? Plus, what is 16? 16 is something as 2 raised to the power 4. Okay? 1 over. What is 4? 4 is something as 2 raised to the power 2. Okay? And what is 2? 2 is something as 2 raised to the power 1. Okay? So now, I can write this one as 2 raised to the power minus 5, plus I can write this one as 2 raised to the power minus 4, plus I can write this one as 2 raised to the power minus 2, plus I can write this one as 2 raised to the power minus 1. Okay? Now, let's rearrange this. I want to rearrange this. I want minus 1 to start. So, 2 raised to the power minus 1 plus 2 raised to the power minus 2 plus 2 raised to the power minus 4 plus 2 raised to the power minus 5. Okay, so now the next thing is for us to use the law of omission and the law of presence. So pay attention. Let's do it. Okay, now let's apply the law of omission and the law of presence. So here, remember, in the law of omission and the law of presence, you concentrate on the power. Okay? And the law of omission and the law of presence says it has to start from minus 1. Okay? Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, like that. So, is minus 1 present here? Yes, if it is present, remember, you put 1. If it is absent, you put 0. After minus 1 is minus 2. Is minus 2 present here? Yes, you put 1. After minus 2 is minus 3. Is minus 3 present here? No, minus 3 is missing. Put 0. After minus 3 is minus 4. Is minus 4 present here? Yes, you put 1. After minus 4 is minus 5. Is minus 1 is minus 5 present here? Yes, you put 1. So that means 27 over 32 in base 10 is equal to, remember, because this is fraction, okay, you need to first put 0 point before you write the answer for the fraction. So the answer for the fraction is 1, 1, 0, 1, 1. Okay, so 27 over 32 in base 10 is equal to 0.11011 base 2. Easy. Now, the last question, I will give you 5 minutes and 5 seconds or 10 seconds to do the last question. And your time starts counting now. Or you pause the video and you quickly use 10 seconds to solve the question. Then you can check the solution. Okay. Now, let's see if you're correct or wrong. D, 25, 27 over 32. In base 10 to base 2. Very easy, right? Okay, now I'm going to give you another method of solving this. Eee! Now let's see how to use another method to solve this. Now let's see how to use another method to solve this. I think I should call this the Robbins method because it's faster. Let's see. Now, you have a 7 over 8 base 10. You want to convert to base 2, okay? what you need to do here is 7 over 8 in base 10. If you divide 7 divided by 8, normal division, that is 0.875, okay? If you use your calculator, just press 7 divided by 8, you will get 0.875. Now, the method that I'm about to explain is this. So 0.875, because you are converting to base 2, you multiply it by 2. So now, pay attention now. So, you do your normal multiplication, but you have to note something here. 2 times 5 is 10, remainder 1. 2 times 7, 14 plus 1, 15, remainder 1. 2 times 8, 16, right? Plus 1, that is 17, remainder 1. And you put the 1 here, that is remaining. You don't multiply this with this. Never multiply that, because this is the whole number part. You are only interested in the fractional part, which is here. That is why we don't multiply this with the whole number part. So let's continue to multiply. 2. So 2 times 0 is 0. 2 times 5 is 10. Remember 1, put 1. So 2 times 7, 14 plus 1, 15. Right? So we put 1 there. Remember, you don't multiply this with this, like I said. So multiply again. You continue to multiply. 2 times 0 is 0, 0. 2 times this one, 10. Remember 1, put 1 here. Now, the point where you are going to stop multiplying is when all the numbers after decimal is 0. You see, this is my decimal here. All the numbers after decimal is 0. So that tells me that is the point to stop. Here, you see, after decimal, I still have 7 and 5. It's only this one that is 0. So I continue to multiply. Here, after decimal, I have 5, 0, 0. So I continue to multiply because I still have 5. But here, all the numbers after decimal is already 0. So I stop. So it tells me that 7 over 8 in base 10 is equal to, now see, so what do we have here? 1, 1, 1. That is the fractional solution for that part, for that base. So in this case, remember I told you before you can write your solution for fraction, you have to put 0, which take care of the whole number part. So what is the answer for the fractional part that you got? This. You always put start your answer from here. So which is 1, 1, 1 base 2. If you go back to the first method that we use to solve for 7 over 8 in base 10 to base 2, you will see that we arrive at the same solution. Don't worry about that. I will take the one for 27 over 32 so you understand. Let's dive right into it now. Now, let's take the one with 27 over 32, okay? I don't have to solve this one here because this one, 7 over 8, is same thing as this one that we just did. So let me do for this one, okay? So C, 25, 27 over 32 in base 10. We are converting to base 2, okay? Base 2. Remember, there is whole number part of this. You already know how to do this, definitely. You are converting from base 10 to base 2. This is successive division. From my previous video, you can check that out. So this is going to be divide by 2, okay? So this is 12, remainder 1, 2, 6, remainder 1, 2, 3, remainder 1, 2, 1, remainder 1, 2, 0, remainder 1. So you already know this. So 25 in base 10 is equal to 1, 1, 1, 1, 1 in base 2. Now, let's go to the fractional part. 27 over 32 in base 10. We are taking that to base 2, okay, which is this part here. So 27 over 32, okay. Divide 27 divided by 32, normally using your calculator. That will give you 0.8432. 375. Okay, so now let's apply the Robbins method. So 0.84375. remember, you are converting it to base 2, so that means you multiply by 2. You do your normal multiplication, okay? So this with this, 10, remainder 1. This with this, 14 plus 1, 15, remainder 1. 2 times this, 6 plus 1, that is 7. 2 times 4, that is 8. 2 times 8, that is 16, remainder 1. You put 1 here. Remember, you don't multiply this with this because this is whole number. You only deal with the fractional part. Okay? So let's multiply. Remember, you continue to multiply until all the numbers after this decimal become 0. This is already 0, so we need to make all this 0. So 2 times 0, 0. 2 times 5, 10, remainder 1. 2 times 7, 14 plus 1, 15, remainder 1. 2 times 8, 16 plus 1, 17, remainder 1. 2 times 6, 12 plus 1, 13, remainder 1. You put the 1 here. You continue to multiply. This is 0, this is 0. 2 times 5, 10, remainder 1. 2 times 7, 14 plus 1, 15, remainder 1. 2 times 3 plus 1. 2 times 3 is 6 plus 1. That is 7. Remainder 0. Okay? You continue to multiply because everything needs to be 0 after the decimal. So multiply by 2. 0, 0, 0. 2 times 5, 10. Remainder 1. 2 times 7, 14 plus 1, 15. Remainder 1. Continue to multiply because you want everything to be 0. So 2 here. 0, 0, 0, 0. 2 times 5. 10, remainder 1. Now, everything is 0 after the decimal. So it means that you are going to stop. Now, your solution on the fractional part becomes this. So, 27 over 32 in base 10 is equal to, remember, before you write your solution for the fractional part, you always put 0 point because 0 takes care of the whole number part. So what is the solution for the fractional part? 11011 base 2. 11011 base 2. So therefore, I can tell you categorically that 27 over 32 in base 10 is equal to, what did we get for the fractional part? And for the whole number part? 11111. Right? Now, what do we get for the part? This. So 11011 base 2. So this is how to use the Robbins formula, which is the order method. Thank you for staying to the end of this video, and I will see you in my next video. Bye.